Okay, so in this video we're going to talk about simplifying radicals, operations with radicals, rational exponents, and equations with rational exponents. This is your study guide review for your Unit 6 test. Okay, so let's look at our very first problem. So we just want to simplify this radical. So the first thing that I want you to take notice of is that it's a square root. So you need to be looking in your perfect squares list. So I'm going to write this as -2 times the square root. Now I need to break everything down into perfect squares. So I need to figure out what perfect square is in 432. Now sometimes it just depends on how you want to start. Sometimes it's easier to start from the bigger end. Sometimes it's easier to start with smaller numbers. I'm going to choose to start at the small end this time and not even use perfect squares. To see if it's divisible, I know that 432 is even, so I'm going to try dividing it by 2. 216 is not a perfect square, so I'll try one more before I go to the other side. So 432 divided by 4 plus 2 is 6 plus 3 is 9, so it is divisible by 3. 144 is a perfect square, so I know that I can use that. So I'm going to do 144 times 3. Okay, then I need to break down the remaining. So 18 is divisible by 2, so we can use our shortcut. We don't have to rewrite this. 9 is not divisible by 2, so we can rewrite that as n to the 8th times n. So then we need to figure out what's staying and what's going. So 144 is a perfect square, so we can take the square root of that. We cannot take the square root of 3. We can take the square root of m to the 18th. We can take the square root of n to the 8th, and we cannot take the square root of n. So I have -2 times, so I'm going to take out everything first. So the square root of 144 is 12. The square root of m to the 18th, remember it's 18 divided by 2 is m to the 9th. And n to the 8th, 8 divided by 2 would be 4. And then what's left under our radical is what's circled, which is 3n. So the last thing that we have to do is do that multiplication. Be very cautious that you put a multiplication symbol there so that you remember this and this notation is the same whether there's a multiplication symbol there or not. But sometimes just putting it there will help you remember that you're supposed to multiply. So it'll be -24 m to the 9th, n to the 4th, square root of 3n. And that would be my final answer. Okay, second problem, same thing. Notice this time we're taking the cube root. Now some of you have a tendency to write this a little strange, so make sure it's small and down in that index where it's supposed to be so that you don't think it's a coefficient of 3 or an exponent of 3. So I know that that negative needs to come first because it has to come out of my radical. So I'm going to try and figure out the perfect cubes in 108. I happen to remember that 27 times 4 is 108, and 27 is a perfect cube. It's 3 cubed. So then I need to break down a to the 7th. So 7 is not divisible by 3, but I can write it as a product of a to the 6th times a. So we're going to do that same process. 27 is a perfect cube, 4 is not, a to the 6th is, a is not. So we have 5 times, the cube root of -27 is -3. The cube root of a to the 6th is a squared. 6 divided by 3 is 2, not 3, times the cube root of 4a. So the last thing I have to do is multiply -15a squared, cube root of 4a. And that's my final answer. So again, same process. We're just going to look at our 4th root. So I have 3 times the 4th root. So 768. Going to go to my calculator. 768. I know is divisible by 2. So again, I'm going to try that small end first. 384 is absolutely not on my list. Let's do 768 divided by 3. Now 256 is in my list of perfect fourths. 4 to the 4th is 256. So I can use that. So I'm going to go back to my problem. And I'm going to use 256 times 3. Now I need to break my 17 up. 17 is not evenly divisible by 4, but I can write that as a product of p to the 16th times p. And the same with q to the 9th. It's not evenly divisible, but I can write it as a product. So remember, I'm going to take the things out that are perfects, leave the things that aren't. So I have 3 times, now the 4th root of 256 is 4. The 4th root of p to the 16th is p to the 4th, and the 4th root of q to the 8th is q squared times the 4th root of 3pq. So again, that last thing that we have to do is multiply. So I have 12p to the 4th q squared times the 4th root of 3pq. Again, I want to caution you to watch your notation. Make sure that 4 is snugged down in that index of that radical, or you're going to think that instead of it being a root or an index, you're going to think that it is a coefficient or maybe possibly a power. Okay, so remember to add and subtract radicals. The radical part has to be exactly the same. So first, there's nothing I can add and subtract here. So the next thing I'm going to try and do is simplify each radical. Now, because I know that I can't do anything with the square root of 3, I'm going to try dividing each of these radicands by 3 to see if it yields a perfect square. And for 75, it obviously does. 25 times 3 is 75, and 108 is also divisible by 3, and that is 36 times 3. So I'm going to just start simplifying. I have the negative square root of 3 minus 3 times. Again, that times is not necessarily necessary, but it will help you to make sure that you don't add and subtract. You cannot just add in a negative or a positive sign. So that'll be 5 square root of 3. Square root of 25 is 5. Plus 2 times the square root of 36 is 6 square root of 3. So I'm just going to multiply. So I have negative 15 square roots of 3 plus 12 square root of 3. Now remember, these are our boats. So our boats are exactly identical. So if you need to, you can go to the calculator. You would do negative 1 minus 15 plus 12. And that gives me negative 4 boats. So I have negative 4 square roots of 3. Okay, so this is the same thing. Again, the first thing that you want to take notice of is that these are not all the same index. So I know that they're not going to add and subtract together. So I know that whatever happens with this one, it cannot possibly in any shape, form, or fashion go with these two. But I still have to simplify it. So I have the cube root of 135. So that's 27 times 5 minus 2 times the 4th root of 405, which is 81 and 5. And 3/4 roots of 5. So notice that once we simplify, the radicand for each of these will be the same, but the index will not be, so they can't be put together. So the cube root of 27 is 3. Cube root of 5 minus 2 times the 4th root of 81 is 3. 4th root of 5 plus 3/4 root of 5. So I have 3 cube root of 5 minus 6 4th root of 5 plus 3/4 root of 5. Okay, so this one I can't do anything with because I don't have another cube root, and 5 is not a perfect cube, nor does it contain a perfect cube. So this says I have 6 of them. Negative 6 plus 3 would be negative 3/4 root of 5. And that would be our final answer. Okay, so this is just a multiplication problem. Remember, we multiply like parts. So when I multiply here and here, I'm going to multiply the coefficient, an understood 1 times coefficient, which is 2. Radical times radical, square root of 10. So then I'm going to do it again. Coefficient times coefficient is negative 5. Radical times radical is the square root of 4. So here to here, coefficient, understood 1 times coefficient is negative 2. Radical times radical is the square root of 25. Coefficient times coefficient is a positive 5. Radical times radical is the square root of 10. So I'm going to start simplifying and combining like terms. So these are like terms because they're exactly the same. Square root of 10, square root of 10. So I have 5 of them. You have 2 more, so you have 7 square roots of 10. Here, these are perfect squares. So I have 5 times 2 minus 2 times 5. So I have 7 square root of 10 minus 10 minus 10, which is 7 square root of 10 minus 20. And that's it. So here, remember, when I have a radical over a radical, the first thing I'm going to check is to see if it simplifies. So see if it's divisible. So 294 divided by 6 is divisible. That is going to be the square root of 49. a to the 7th divided by a to the 3rd is a to the 4th. B to the 14th divided by b squared is b to the 12th. Okay? So then from here, I'm going to start simplifying. So it is a square root, so I don't have to do anything with 49 because it's a perfect square. I don't have to do anything with a to the 4th because it's divisible by 2. And I don't have to do anything with b to the 12th because it's divisible by 2. So that's going to give me the square root of 49 is 7. The square root of a to the 4th is a squared. And the square root of b to the 12th is b to the 6th. So the next one, notice we have this radical in the denominator. So we're not truly going to be dividing by the square root of 8. We're just going to rationalize that radical out of the bottom. So I'm going to multiply by the square root of 8, top and bottom. So remember, coefficient times coefficient, an understood 1, so 5. And the square root of 5 times the square root of 8 is the square root of 40. Over the square root of 8 times the square root of 8 is the square root of 64. Or we could have written that as the square root of 8 squared. Either way, it's going to yield the same answer of 8. So the last thing that we have to do is make sure that my radical and my coefficients are simplified. So I'm going to start with my radical. So 40 is not a perfect square, but it does contain a perfect square of 4. So I have 5 times 2 square root of 10 over 8. Now before I multiply here, you can go ahead and simplify that 2 over 8 if you prefer. So we could go 2 over 8 is 1 over 4, so that's 5 square root of 10 over 8. Now if you're not good at simplifying that way, you could just simply do 10 square root of 10 over 8. And then you can simplify the 10 over 8 by a factor of 2. You can put it in your calculator, math in your enter. And either way, you're going to get 5 square root of 10 over 8. So this one, notice we don't have just a single term in the bottom, one solitary term. This is a binomial instead of a monomial. So because of those two, we're going to multiply by the conjugate. Remember that the conjugate is simply the same term with a different center sign. Oh. And I wrote my coefficient as the index, so be cautious. 3 square root of 2. So it's just distributive property. 2 times 5 is 10. 2 times 3 square roots of 2 is 6 square root of 2 over. And then we're going to FOIL in the bottom. So we have 25 plus 15 square roots of 2 minus 15 square root of 2 minus 9 square root of 4. Now, two things, remember, should always happen in the denominator. The first is that these two terms should cancel out to 0. If that doesn't happen, you didn't multiply by the conjugate, so be cautious. So I have 10 plus 6 square roots of 2 over 25 minus, so this is going to be minus 9 times 2. Square root of 4 is 2, which is 18. So I have 10 plus 6 square root of 2 over 25 minus 18. Which is just 7. Okay, so again, the last thing that we're going to do before we call ourselves done is we have got to check that all of our radicals are simplified as far as they possibly can be. Well, the radical we have is just the square root of 2. It's not a perfect square. It doesn't contain a perfect square. Then we're going to check our coefficients. 10, 6, and 7 don't have a common factor, so we can call ourselves done. Okay, so we want to write these. This is the big thing, simplest radical form. So the first thing is we want to apply those exponential laws to get it as simple as possible and then write it as a radical. So product rule says that we add when we multiply like bases. So that's x to the 8 over 7. That won't simplify, so I'm going to do the 7th root of x to the 8th. Remember, it is power over root. Don't get this confused or you will get it wrong. Okay, so this is not simplest form because my exponent is larger than my index. So I have the 7th root of x to the 7th times x, which is going to give me x times the 7th root of x. Quotient rule says when I divide two like bases, I subtract their exponents. Remember, there's an understood 1 here. For there to be a k, it has to be k to the 1. So that would be k to the 7 over 2. Again, 7 over 2 doesn't simplify, so I'm going to do the square root of k to the 7th. So we have the square root of k to the 6th times k. And 6 divided by 2 is k to the 3rd times the square root of k. So here, again, these have two different indexes, so we can't just multiply them the way they sit. So we're going to change this to exponential form. So m to the power of 1 divided by 2. Remember, if there's no index, it's an understood 2 times m to the power over the index. So the first thing that I notice is that this will simplify. So I'm going to do 1/2 to the 1/2. Now when we multiply two like bases, we add their exponents. So that would be m to the 1, which is just simply m. Okay, so remember, if we want to solve something that has a radical or a rational exponent, we have to get it on a side by itself. So we're going to add 3 first. So we have the square root of 2x plus 1 is equal to 8. To get rid of a square root, we square, and if we do it to the left, we have to do it to the right. So I have 2x plus 1 is equal to 64 minus 1. So I have 2x is equal to 63. So x is equal to 63 divided by 2. Now, in order to check that answer, we want to plug it in. I would plug it into just the left side and see if I get 5 out. So I'm going to go to my calculator. I'm going to do second square root 2 times 63 divided by 2 plus 1, and I'm going to make sure that I come out from under my radical. If you're in an older calculator, you would use parentheses, and then do minus 3. And it is 5, so that is absolutely my solution. So I can now box that answer in. So remember here, this is already on a side by itself. So remember that the 1/3 power is the cube root. So I'm going to cube both sides. If you get confused, these should multiply to be 1. So if you 1/3 or 1/3, you get 1/9, which is not 1, which is not the correct operation. So I have 2a minus 3 is equal to 8. So plus 3. So I get 2a is equal to 11 divided by 2. I get a is equal to 11 over 2. Now before I call myself done, I am absolutely going to plug that back in to make sure that that's correct. So I'm going to go to my calculator, and I'm going to do parenthesis 2 parenthesis 11 divided by 2 close minus 3, and I'm going to do close parenthesis, that whole quantity raised to the, and if yours doesn't do this right here where it's an does the exponent for you, you will have to use parenthesis. 1 divided by 3, enter, and it is 2, so that is absolutely a solution, and you will box that in. So remember, if it doesn't work out, it could be a no solution, so don't panic, double check it and make sure it's right.